All right, good evening. This is another session of live training from Unity Technologies. And my name is Adam Buckner, one of the several live trainers that we have now. Today's session is converting the space shooter project that we have on our Learn section to mobile. It's going to be a bit of a hang on to your hat session. There's a lot to do. My notes are quite thick, because I want to cover some things that are theory, I want to cover some things that are practical. So you should expect to run late. We try to make them about an hour, and there may not be a huge amount of Q&A, but just to let you know, it's a big one tonight, just due to the sort of volume of the stuff that we have to do. So, mobile development. What are we doing? We're converting this project to mobiles. And what is a mobile and why the difference? Let me go ahead and bring up Unity, and then we'll start looking at some things on the web. So mobile development, mobile devices. Let me bring up, and I've got some links. Some of the main differences between standalone downloadables and mobiles is the fact that, well, you don't have any buttons. You don't have any, you don't have that same user interface. You just have usually a big slab of glass. Now, this is not a Unity game. This is a game, World of Tank Blitz, which is a mobile game, usually on tablets. And the reason why I bring this up is this goes to show some of the advantages and drawbacks of moving a game to mobile. You have to find some place to put all of your controls. All of your controls are going to sit there on that screen itself, on the canvas. Your fingers are going to get in the way. You have to find a place to put them. You don't get that tactile feedback. So one of the things you have to consider when making a mobile game or converting to mobiles is to consider the UI and to consider whether the game is actually something that's going to work well when you get it onto your mobile device. Now, the two main input schemes that we have on mobile devices are the accelerometer. What the heck is an accelerometer, you say? Well, heck, I've got a little picture of that as well. Not very useful. It's a little widget that sits inside the device and figures out which way the G-forces are in the device. And usually that's just simply gravity. It's simply showing you where down is. But you can manipulate that to be able to move and tilt your device, to be able to get input from the device itself. So we have these two interfaces. We have the ability to touch the screen. We have the ability to touch the glass on the screen. And we have the ability to move the device itself as our two sort of main input methods. So everything that we're going to be doing tonight is going to be looking at converting the input from keyboard and mice to moving that input to using either the accelerometer or using touches on the face of the device. Now, what device do I have? We're not going to see it. I'm not going to plan on showing you the device because I don't have the webcam set up, but I have my iPad here. But we can convert to quite a few different mobile devices. And these mobile devices are also going to need some additional SDKs. So the most common one that people know about, there's iOS, and so you've got to go to the Dev Center for that. And I'll put these in the chat channel in a second. But for Android, you're going to need the Android SDK. And for Windows, you're going to need an SDK for that at the Windows Dev Center. So you're going to need additional software as well as your computer. So you'll need Unity. And then you're also going to need to get the SDK from the platform that you're building to. And as we know, Unity can build to all of these platforms and more. So that's not a problem. And you just need to get accounts with them. I don't know actually that much about Android and Windows development. I haven't had the chance to do it before coming to Unity. I did a significant amount of iOS development. To get a license from them, it's not free. It's still $99 a year. So some of this may take a little bit of an extra cost. So before you get started, you need to have Unity, and you also need to have the SDK for the mobile platform that you are building to. Now, what are we going to do today? We're going to convert Space Shooter. So I think the first thing I want to do is go out and get it. So we all know where it is. Move that off. And we can get that from the asset store. And the asset store is going to open up in the other window. Yay, come on. We're going to be looking for Space Shooter. And we can simply do that by searching for Space Shooter. And there are several people who have used Space Shooter as a template, like these people up here, to go and show off their package. So make sure you get the one from Unity Technologies that says Unity Technologies and has our little blue Learn logo on it. And then we just can go ahead and import that directly into our project. So when that comes down, in another window, there we go, import. So we have that in. We've got... we now have imported this project into Unity, and you can still see that our build target is PC, Mac, and Linux standalone, because we know that when we're reading the header, we can see the scene that we're in, we can see our project, which I pre-made, which is Space Shooter for mobile, and then our build target, which is PC, Mac, and Linux standalone. Now I'm going to bring in one other chunk of art, some mobile artwork that I made that we'll need for this later on. So I've got some mobile art. So that's essentially what we have for this point, and we'll bring some additional things in if we need them. And we're going to go to the done scene at this point, and we're going to go into the done folder, into the done scene, and run done main. And this is going to be the example scene in the project. If you finish your own game, if you've done some custom mods, then you can go ahead and run this off of the finished scene that you have completed. And I'm going to move this just so that we have this to a different layout so that we can see that up there. And I'm going to move from free aspect down to a tall version, something like that. So now we have that loaded up. The first thing we want to change is our build target. And we can do that by going to the build settings, or Shift Command or Shift Control B. And that'll bring up in another window. We'll bring up our build settings. And we want to change that from Mac, PC, and Linux standalone to iOS. And then we're going to simply say switch platform. And when we do this, we're going to see this is going to re-import our assets. It should be relatively quick. I do have asset server running, but since this is a brand new package, it won't have saved anything to the cache server, into the cache server. But it's a small project, so there we go. We're done. And we now are in, we can see this up here. We can see Space Shooter for mobile, iPhone, iPod Touch, and iPad. Let's put that back on something sort of mid-range, iPhone 4 tall. And so we've got build settings. We need to also take a look at our player settings, because we're converting this from standalone. We want to change the player, and we're not talking about the player settings, a little bit deceptive, as the person who's playing the game, but we're talking about player settings in this case as the player, the web player, the standalone player, or in this case, the iOS player. And so we can do that by going to the player settings, and that'll bring up the player settings in the inspector, or we can do that by going to edit, project settings, come back here, and player. And that'll bring up the player settings. There's a couple of things here we want to change. Things that often are ignored when you're doing web and standalone because they're not needed. I'm going to change my company name here. Let's just make this Unity Technologies. And then we have a default icon which we need to set, and that's what we have in our mobile art. And I'm going to go ahead and we'll include this in the package when we put it up. And so there's our mobile icon. A little mobile little icon that I made based on the artwork in the game. So, and this is relatively large. And you can see that this is 512 by, and you need to look at the requirements for your particular build platform, and you'll discover that they are quite high resolution images that you need when you're going to mobile platforms. Especially for Apple, because they're going to be using this to make things on their storefront. They're going to be using this to make things on the devices. So let's go ahead and, come back to our player settings, please. Player settings, And then let's go ahead and put in our default icon, and that'll make our default icon. I'm going to quickly go down to icon, and you can see that it has populated all of the different resolutions for us, which Unity is very nice about. While we're here, let's look at the splash image. We need to have splash images for all of these to be able to submit to the App Store, and I would presume that's going to be the same for mobile development if you're going for Windows Phone and for Android. And because as the devices get more devices and more resolutions, you're going to need more different sizes and shapes. In our case, we can simply populate them all with this one large mobile splash screen that I made, and this will be enough to satisfy the Xcode in this case when it builds it, so that it says that we have all of the required images, and I'll show you what that image looks like in just a second. Bink. And so this is the image. We're going to make some changes when we go ahead and look at artwork because it's come in square. So what we've done is we've populated our icons. Going back to our player settings, we've populated our icons, we've populated our splash images. So let's talk about resolution and presentation. Because the devices that we're dealing with can be used at any orientation, which is very different from often computers with static monitors, we need to set what that default orientation is. And in my case, for this device, I'm going to go ahead and pick auto rotation because we want to be able to have the user use this in any of the possible rotations. We still want it to be in portrait, so we don't want to have any of the landscapes. So let's go ahead and just run that as portrait and portrait upside down. And with auto rotation on, the device will be able to flip that orientation back and forth if you change the device. And we'll leave everything else pretty much as default. Status bar will stay hidden, so we don't get to see that little header bar at the top. And other settings. The only thing that I'm going to change down here is the ant ranch. And I'm going to leave everything else here pretty much at default, including my target, which is going to be iPhone and iPad, and we'll use the native device resolution, and then we'll leave this at our graphics level of just OpenGLES 2, just for now. This is more advanced stuff, but for now, this will go ahead and it will go ahead and run. If you want to set up for Android, there are similar settings that we have here for Android and similar settings we have here for BlackBerry. And I may not have the module for Windows Phone. Windows Phone 8 down here. Now that we are roughly set up for our build target, and we have our additional artwork, let's take a look at this in the game view. It looks not too bad. Let's take a look at our textures, because these have come in now. They've been re-imported for mobiles, and they'll be using new import settings. Don't forget that we have our default import settings, and these have not changed. They're going to come in at their max size that was set in the original project. Usually it's going to be 128 for a lot of these, and some of them will go up to 512. But generally, these are kept relatively small, with the exception of the background nebula. And what I do find is that the compression on mobile devices is relatively more harsh than it is than a similar setting of compression when you're dealing with standalone. And if it doesn't look good enough, then sometimes you find that you actually have to bring up the quality level a little bit. I mean, in this case, I think it works just fine, and we could probably have kept that as compressed. So you could bring them up as 16 bits or true color, but then realize that you're stressing out your device. Part of the reason that we have relatively more harsh compression when you're dealing with the compression styles is not only is it something that runs quickly on the device, but the devices themselves are relatively underpowered compared to standalone computers. So you do want to make sure that you're keeping your items as compressed as possible up to the point where it is detracting from the game. And I don't know if you can see this on the Twitch feed. When I do that, this does get visibly blurry when I have the thing on, when I have this texture being imported on compression compared to either 16-bit or clearly true color. So I'm going to leave this at 16-bit because I think our background here looks significantly better, but not enough for pushing it all the way to uncompressed true color. So be aware of the settings, and also be aware that you can override them. So if we want to leave this as compressed by default, and we want to change this only for our mobile, we can override for the iPhone, and we can change our compression, make that 16-bit, and apply. And in which case, this compression scheme is only going to work when we have our build target set to the iPhone. Now, if we enter play mode, oh, I forgot about the volume. It's going to be kind of loud. Some of the things I'm going to turn off the sound because I'm not playing it back here, and I don't want it to get in the way of what I'm saying. So I'm going to go to the game controller, and just for this particular case, I'm going to turn off the audio source now for the background music, and throw a big flag in the chat channel if this other sounds like the explosions and that sort of stuff get too noisy, because right now I don't have that feeding back to me. So one of the things that we're going to notice is that the graphics for the sprites aren't working well. And I can move around using the keyboard, but I'm not going to have that keyboard available. So, I'm not going to be able to use any of my input schemes that we have. First thing I want to do is go back and change the sprites that we have, because they're looking kind of ugly. And that's these guys here. And I'm going to override those for the iPhone, and I'm going to make them true color. They're relatively small, and this should make those look a little bit better. There we go. That's starting to look a little better. So with our artwork ready, and the fact that we can still play, but it isn't playing the way we want to, and we can't move it if this works on the device. So we need to update our code to work with mobile. It needs to work with either touch input, or it needs to work with accelerometer input. So let's go ahead and take a look at our control schemes. We have these two control schemes. We have the input methods with the accelerometer, and the input with the touch. So let's go ahead and take a look at some scripts. So let's go ahead and open up, again, we're dealing with done. Let's do with our done scripts. And then we're going to open up our player controller. Moderately big script. I think that that's enough for you guys to see. Yep. So currently, when we're looking at our movement, we're moving in the fixed update function, where we get our move horizontal and our move vertical from those input get axes. So input get axes horizontal, input get axes vertical. That moves. We take two floats, move horizontal and move vertical, and we turn that into a vector 3 for our movement with our move horizontal and move vertical, and we don't move at all on the y-axis. Well, we can change this very simply by going out and grabbing the accelerometer. For touch input, we're going to need something that detects touches, and we're going to use the new UI tools for that. But we'll do that as a sort of a second maneuver, second look. I also have something else that we're going to run into, and you're not going to see this. You can hear that's the cover to my iPad. I realized I need to show you this as well. Unity Remote. Unity Remote. We can control the input on the touch device, and it will show in the editor. And we do that by using the Unity Remote. And the Unity Remote, you can get the source and you can build it, but at the same time, it's just as easy to go to the App Store and just simply download it for your device. With the remote, I'm going to be able to touch the device in front of me and use that as input instead of the keyboard itself. So to set that up, you need to download that to your device. I have the device hooked up to the USB port, actually to a USB hub here on my desk. And then in Unity, you need to go to Edit, Project Settings, Editor. And then Unity remote device needs to be any, in my case, any iOS device. So now I have my remote set up. I've already downloaded that onto my iPad. I could show it to you right now, but it wouldn't do anything because right now there is no input that we have enabled inside any of our scripts to accept any of the input that would come from the remote. So the remote would be working, but we don't have anything accepting that input. So let's do that now. Coming back to MonoDevelop, again, we were talking about removing or replacing our input that we're getting here. So I'm going to comment these out, and that's our move vertical and our move horizontal. I'm going to take part of this line, the vector 3 movement, so I'm going to copy and paste that, and then comment out that first part. And I'm going to write, I want a vector 3, and it's going to be called acceleration. And our vector 3 acceleration is going to be equal to input dot, surprisingly, acceleration. So we can ask our input, the input class that we have in Unity, to simply look at the current device that we're dealing with and get the acceleration. So we're looking at the accelerometer that we have right now, which is 3 axes, X, Y, and Z, and shows the direction of the g-force. Usually, as I said, it's the direction of gravity, so we can know it's the direction of down. And then we need to use this acceleration, and we can do that with our movement. The reason why I wanted to keep this line that we have here, the movement, is because all of the rest of our code deals just fine with what movement is. I mean, primarily just this line here, movement times speed, goes into our rigid body velocity. But what we want to change is where we're getting our input from. So now what I want to do is write our acceleration dot x and 0 on the y, actually a 0 please, 0 on the y, and then we want acceleration here to be dot y. Because of the difference of the orientation of the device, what we're looking for here is acceleration x and acceleration y. And then this will give us our movement value, and then that becomes rigid body velocity is equal to our movement times our speed. And the input's going to be slightly different than we're going to be used to from our keyboard, so we may have to change our speed value. So now let's go ahead and save that. Let's come back to Unity. Pray to the compile gods. What are they saying? Oh, F. Silly me. Nobody even piped up. Usually you guys pipe up and tell me that I've made an F. So anyway, so that there we go. There's our F. Let's come back to Unity and let's see it compile. There we go. All right. Now, I've got the remote in front of me with my device running, and we have to actively be running the remote app on our device, and it will say, make sure that you've connected this device with the USB cable to your computer and hit play. Now, when we hit play, this should work. There we go. So I'm tilting the device to maneuver around. Failed miserably. One of the problems with this easy and direct code is I need to hold the device parallel to the floor. So completely flat. And I can't comfortably hold it up in front of me. Because if I comfortably hold it up in front of me, when we hit play, when I hold it up in front of me, I'm slammed there against the bottom. Let's see if I can't fire. I'll explain that in a second. But because the device is tilted back with the bottom end towards the floor, I'm not moving forward. The only way to move forward is to tilt it away from me. And to change this, we need to calibrate what our 0 point is when we're dealing with the accelerometer. And I have a very sort of simple couple of lines of code. This all has to do with transforming our quaternions, which I don't really want to get into, our fourth dimensional maths, transforming our quaternions. But I will walk you through slowly, stage by stage, what we're going to be doing here, because we essentially need to make calibration code to be able to calibrate where our starting point is, so that tilts from that starting position is what Unity will use to influence our acceleration. So let's go back to our code. And I need to add two little functions. Void calibrate accelerometer, if I spelled that correctly. So there's my calibrate accelerometer, and I also want to have another quick function, another void fix acceleration. And you'll see how I use these in just a second. Oops, one extra line. Come back here. They're crammed at the bottom of the script. Maybe we got fixed update. I like to have these at the bottom of my script because it's sort of where they go logically, but it's going to be hard to see. So let's just pop this up to the middle. So I've got our calibrate accelerometer and our fix acceleration. Let's get back to copying and pasting. So I'm going to quickly, I'll walk you through these because this will be just as easy. So these are two little functions that I have. Shows you when I wrote these. iPhone input doesn't exist anymore. There we go. Calibrate accelerometer. When we call this function, it takes a snapshot, which is just a vector3 of the input acceleration. And then from that acceleration snapshot, we create a quaternion that we are going to use to set where our original position is. And then we are going to invert it so that we have a calibration quaternion to take that rotation from. So essentially, we're going to take a snapshot of our rotation and we're going to invert it. And then with that inverted rotation, we can then use that to check against what the new calibrations are, what that new acceleration is. And then every frame, we're going to fix that acceleration by sending it our acceleration and then just simply multiply it by our calibration quaternion. And that will give us acceleration that is fixed as an offset from that original position. And what I'm going to do very quickly here is in Start. We're going to call this calibrate accelerometer. Now, in reality, we will probably want to have a button that does this. So, or when you start your game, rather than when the game actually starts up. We don't have any proper framework around this game, but if we had a normal start button, it may say sit back, relax, and hit the start button. We'd also probably have an options button that would allow you to recalibrate. So if you changed your position, you could recalibrate the accelerometer so that you could adjust your position and still go ahead and play. And lastly, what we need to do is change how we use our input in our fixed update. So now we are grabbing our acceleration. So let's change this to acceleration raw. And then we're going to add a line that says a new vector3, which is just going to be our acceleration. Is going to be equal to our fix acceleration. And which one are we going to fix? We're going to fix our acceleration raw. So essentially what we do is every frame we process that acceleration that's coming in. So now if I save this and come back all the way to Unity, and with my device running in front of me, I can go ahead and hit, oops, no I can't if there's an error. So what's our error today? Calibration quaternion. Oh, did I not make that? Sorry, yes. I actually need to hold that with a private quaternion. That's our calibration quaternion. So there's our variable to hold that value. So let's go ahead and save that. Come back to Unity. All of this should just go away, right? Pow. Good. And now I'm going to enter play mode with my device in front of me. There we go. Ooh. So, yes, now I can maneuver the device with my calibrator. based on my original starting position. Now, savvy people will notice that I'm firing, and I've made no buttons. Unity will look at the first touch, and we'll get to touches in just a second. Use those as if we had mouse down 0, mouse 0, the left mouse button, but without setting up any buttons. Since we had a mouse down, it's sensing any of the finger touches that we're doing on the screen and translating that into the same thing as if we were saying get input, get mouse button down 0, or get input, get axis fire 1. So some of the drawbacks to this type of an input scheme is we must position the device to the correct orientation. We have to maneuver the device, which can be kind of embarrassing when you're sitting on the train trying to play a game. Some of this can be solved by perfecting this particular snapshot and making a button for recalibrating. But as much as it was fun to start off with, and there's many uses for the accelerometer, I did want to show that to you. In general, most games do use touches. And touches, I want to show you in the documentation. So if we go to the documentation, and we look at the scripting, and we look at touches. Input touches. All of these devices are slightly different. Android and Windows Phone and iOS all deal with touches in a slightly different way. But they all are looking at the finger touching the glass. And Unity puts them all together into the input touches. The touch keeps track of some very important things. It keeps track of things like the number of taps. It keeps track of the position. It keeps track of its phase, which is important to know about. It keeps track of the finger ID, keeps track of delta time and delta position. And so that delta position can be used for finding drag. How much has it changed? How much time has passed since the last touch has been recorded? Finger ID is also very important because when you're dealing with multiple touches, sometimes you want to know which particular finger is down. And we'll see that when we move forward, when we make our fire button or our movement button and our sort of joypad area, and you don't want a second touch to get in the way and interrupt what you're doing. And touch phase is also very important. We're not going to touch on touch phase today, but I think that you should know that it's there. Touch phase allows you to look at whether this is the first frame that it has touched the screen, whether it has moved, whether it is stationary, whether it's ended, or whether it has canceled, whether the touch is no longer being tracked, usually because the touch has left the screen. And so there are times when you're doing more complex touch analysis where you need to know the phase of the finger. You need to know, is this, I found a new touch? Is this the beginning of it? Has it moved? So you can get that from the touch's touch phase. We are primarily, as much as I'm showing you all of these very important things about touch, we're primarily going to be backing out a level, and we're going to be letting the new UI tools deal with touches for us. But I did think that it was very important for you to look at what touches are and how to deal with them. I mean, a typical thing that you can do here is, if your touch count is greater than 0, that you can then iterate through all of the touches. You can find which ones have just begun. You can add them in. You can grab touches. You can latch touches to use them. What we're going to be using is on the new UI tools, we're going to be using the touch input module. And this is ultimately so that we can change between keyboard and mouse input and touches in the same project. And I don't think we're going to have time to be able to get all the way to that tonight because we're pushing to even get this far. But you can have one project and one code base, and you can deploy to all of your different platforms, including keyboard and mice devices and touch devices, all by the way that you manipulate your code and by the choice of components that you use in your game system. Now, we may get to that if we stick around to Q&A. I may show you a little bit of that where you talk about platform compilation, platform dependent compilation, but just be aware that even if we don't touch on it tonight, that you can put defines inside your code that will define that if it's a Windows phone or if it's an iOS device, then use the touch. And if it's not, then use the keyboard and mouse. Let's start off with our movement, and we'll get to firing in just a second. To do movement, I want to create a touchpad area. There are, just so that you're aware of it, there are, in sample assets and standard assets, there are pre-made prefabs for touch joysticks and touch joypads that you can simply just drop in to your project pretty much and just read the small amount of instructions and you can just go. But I want to show building one of these a little bit from the ground up, because to show you it's relatively simple. So yes, there are some drag and drop techniques, but I didn't think that would really help us in this case in learning anything about what's going on underneath. So we're going to create a sort of touch area. I'm going to go into 2D mode because I'm now going to be starting to use the new UI system. And I want to create a new UI image. Not a button, surprisingly, just an image. So let's go back out and we can see that we automatically have been given a canvas and we've been automatically given an event system, which is what we're going to be sort of pushing around to get this done. And then my image, I want to go ahead and put this in the lower left. So I'm going to stuff it down there in the lower left. And I want this to fill half of the lower end of the device. So if I was to look at the anchors, come here, Mr. Anchor, I sort of want it down in this area somewhere. And what I can do is simply set my anchors manually. I want this to be at halfway. And we're looking at the anchors, which are just the triangles. And about a third of the way up. 0.33 is close, but let's say 0.35. And then a simple way, I can then sort of try to drag these to fit and they will snap. Or I could simply zero out the corners, the top left and bottom and right, because this describes the distance or pad between the corner and the anchor, and I want the anchors and the corners to all be there filling that up. Now, coming back to our game, that looks kind of annoying, covering up the game like that. Well, if we take the image, we can also take its alpha. And we can't turn off the image. We need the image here, and we need the image working. So we don't want it off. We want to take the alpha and set that to 0. So it is still working. It's still there, but it's invisible. And let's go ahead and name this. This is going to be our movement zone. So that gives us an area for our movement. It's our movement zone. And what we're going to be using in the event system is the touch input module. And we also have the standalone input module, and they will work independently of each other depending upon the platform we're on. So the touch input module is going to be working on my tablet. The standalone input module is going to be working when we're here in the editor and on our standalones. But we're going to be writing our code to the touch input, and we're going to be doing our touch input through the Unity remote. So now I need to write a script that'll accept our touch input. So let's go ahead and grab our scripts. I'm going to create a, actually I'm going to do it up here. I'm going to create a new scripts folder called new scripts. I'm going to underscore it so we know at the top, new scripts so we know where they are. And let's create a new C# script. And that C# script we're going to call something, let's call it simple touchpad. And then we'll open that up in MonoDevelop. And I'm trusting it's big enough for you guys to read. So I'm going to remove our sample code. All of it. Not just some of it. And we're going to be using the UI and the UI events. So we want to say using Unity engine.ui and using Unity engine.event systems. What about Android? Question is coming in, what about Android? Everything that I'm doing here works for Windows Phone, works for Android, works for iOS. I just don't happen to have an Android device on me. I have an iOS device, and my background was iOS devices. I've been having a request to make it slightly larger. I hope it's not too large. I'll make it small again if they start popping way off the screen. But remember, what Unity is cross-platform, so, and we have a generic input that works for touches. We have a generic input that works for the accelerometer. So everything that I'm doing here should make it possible to develop this exact same code. Should work fine on Android and should work fine on Windows Phone and BlackBerry. I just don't have those devices here to show you, but the code should be exactly the same. So we've got our simple touchpad. And we've added in our two namespaces, the UI and the event systems. We also need to add some interfaces here. I would like to have I pointer down handler, I drag handler, and I pointer up handler, because we're going to be using on pointer down, on drag, and on pointer up. And as a matter of fact, let's just put those in. So these are going to be placeholders. We have to implement all three. Public void. All of them have to be public void. And then we want on pointer down. Only if it's spelled correctly. And then we also need our pointer event data. And let's just call that data. And then I'm going to be cheeky, since we're going to be skating already. And then let's just pump that out 3 times. And then we want to have on pointer up. Oh, come on. On pointer up. And on drag. So those are the 3 functions that we're going to need. In this first one, what we want to do is set our start point. And I'll talk about this in just a second. And then on drag, we want to, so essentially what we're going to do, let me explain this. I realize that I am pushing. So we have this square, this movement zone, and I didn't want to get into a specific joystick with a specific center point. I want to say that wherever you put your finger down, anywhere inside that zone, and then you start moving or dragging your finger in any direction, you are creating, I guess, a virtual joystick or joypad, but it's going to be centered on the point where you first put your thumb down. And then, so you don't need to get it exactly onto a particular point. So if you put your thumb down a little bit too far to one side or the other, you don't miss. Just as long as it's in that area, you can put your thumb down. You can then move it in any direction, and then you can use that to steer the ship. So when we're dealing with our code, the very first pointer coming down is where we're going to set our start point, and everything is going to move from that start point. On drag, we want to compare the difference between our start point and our current pointer position. And then in our on pointer up, we want to reset everything. So to do that, we're going to need an origin point to set. So let's create a private, there we go, vector2, and let's just call this origin. And in our on pointer down, let's set our origin to be equal to our data, which is our pointer event data, dot position. So we're going to simply set our origin point to the point that our pointer comes down to. And then in on drag, we want to have our vector2, create a vector2, and let's call it our current position. And it's going to be equal to, you guessed it, our data dot position. Oh, come on. So then we take our current position, set that to data dot position. So as we're dragging it around, we take a look at what our current position is. So then we need to know what is our raw difference. So our direction in raw form is going to be equal to the difference between our current position and our origin. What do we want to do with this raw direction? We want to say something, our vector 2, comma. We can get a vector 2 out of that. Vector 2 direction is equal to our direction raw normalized. So if we don't know what normalized is, we'll have a quick peek in another window. There we go. So when you're dealing with vectors, and this is true for vector 2, vector 3, we can normalize our vector. And so it's going to have a magnitude of 1, but it will continue to keep its direction. The vector will be unchanged in its direction, but it's going to be normalized to simply a value ultimately of 1. So we want to normalize that value. And then just to show that it's working, let's just throw this in the log, debug.log, our direction. And that is not a correct word, direction. So let's copy that, paste that in. So debug.log, our direction. And then ultimately, we will want to reset stuff when we get that back to the on pointer up. But at this point, there's nothing that we want to look at. So let's just make sure that everything's working. And I haven't made any more bonehead coding errors. Okay, that's looking fine. And I'm going to turn off my game controller for right now so that we're not going to be spawning too many enemies. And the other thing I'm going to need to do, let's just turn that off at the player, is we're just looking at our input. So let's save that. Let's hit play. And this should show in the log down at the bottom. Oh, because I haven't attached the flickin' script. Good God, I am Russian. So yes, apply the script. Very useful and helpful thing to actually have the script applied at the time that you want to use it. There we go. So now you can see the debug.log in the lower, if you can peek down here in the lower left. It might be small for you at home, but those values are changing as I set it down and then move my finger around. So we can tell that our touchpad is working by looking at the debug.log. And so we know we're going to get viable input and viable normalized input by looking at the log. So coming back to scripting, we now need to do something with that direction. So let's take that private vector 2 direction, and we will also reset that. So now we've done something with our direction. We don't need this debug.log right now. And when we're resetting, when the pointer comes up, let's say our direction is going to be equal to vector 3 dot 0. And we should also prep that direction in awake. So what we're doing here is we've made a new value to hold our direction so we can pass it off. And we are going to set direction at the beginning to vector 2 dot 0. So it's got no direction. And then when our pointer comes down, we have an origin position. We look at the difference between the origin position and we set direction. We can't, so we just simply set that direction that we're holding to that normalized value. And then we create a public function that we can grab that value from. Public, and it's going to return a vector 2. Let's call it get direction. And it's going to return direction. And this allows us, if we have access to this script, it allows us to grab that direction from our player. So let's return to Unity. Make sure that we haven't made any silly mistakes. We have. Where am I today? I can tell, semicolon. Good. And then now we do need to comment on our tilt control. So let's go back to our player, our done player, and we'll need that control script back and working. But let's look at our player controller. And we don't want these tilt controls right now. And we're going to need access to this script. So up here with our public variables, we want a public simple touchpad, and let's just call this our touchpad. And back in our fixed update, our vector3 movement, let me just copy this, and just so we have our old code sitting there. Our vector3 movement is going to be equal to our direction. Let's go ahead and grab that. So we're going to create a vector2 direction. That's going to be equal to our touchpad dot get direction. So we're going to grab that direction from our other script, which we're going to have to link. And then we want our movement now to be equal to our direction x 0.0 and our direction y. So we're simply grabbing that input that we have from our touchpad, and we're applying that to our movement just the same way that we grabbed our acceleration, except we're now going to be grabbing that direction that we make as the difference between where our thumb comes down and where we move that. So let's, again, pray to the compile gods, see how we're doing. And oh, we're going to need to associate that as well. Look at those yummy Christmas lights we've got in the console. So our done player, now we have our touchpad, so that we need to grab our movement zone and put that into our touchpad. Save that and go ahead and hit play. And now we can move our spaceship around by using the touchpad. And you don't see it, you don't see my thumb moving around, but it is. So we're now using that touchpad to move the ship. But one of the things that is that if you look at it moving, it just immediately goes to movement. It doesn't have that nice feathered feeling that it had when it was getting the input get axis, where it would move towards the value of 1. So it would start off with a value of 0, even though you hold down the button, and would move it up towards 1. It wouldn't just snap to 1 unless you used input get axis raw. So let's quickly look at smoothing this information. So again, coming back to monodevelop, and then looking at our simple touchpad, we're going to need some more information. This one's going to be public. It's going to be a float called smoothing, and we want a smoothing value. And then we also, since I'm going to be using move towards, need a private vector2, which is going to be our smooth direction. So that's our smooth direction. And then down in get direction, we want to say our smooth direction. Oh, come on. You should be able to complete that. Smooth direction, thank you, equals, sounds like something off of the X Factor, smooth direction. Anyway, so smooth direction is going to be equal to a vector2 move towards. And this is a little bit like a lerp. We talked about that in one of our other classes. What the vector2 move towards is compared to lerp. So if you're unclear what move towards is, go ahead and take a look at that archive. And it's going to move towards between smooth direction and our smoothing value. And then we want to return, not direction anymore, but our smooth direction. So what we've got here is a value that we're gonna set, and then as opposed to just returning the raw direction, we're going to smooth it out with a move towards. So every frame, we're going to move towards that direction value from our smooth direction, maxed out by our smoothing value. And also we do it out here, not in the on drag, because otherwise it would snap as soon as we lift up. So it would have a nice smooth entry as we started to pointer down and started to drag. It would look really nice. We'd lift up our finger and it would snap, because in our on pointer up, we're setting our direction back to that vector 3, 0. So we want to smooth between everything, including that value that we zero out to. Getting back to the game. Let's save this. I'm going to go ahead. We know where that movement zone is, so I'm going to go and return that back to being completely empty, completely clear. So let's save. I've got my iPad here with the remote. Hit play. And now, we should set a value. It's amazing how I keep thinking these are going to be done automatically or by my servants. My movement zone needs to have a smoothing value. That's going to be 0.1. So that it will only move towards that value. And now we should see that it's got that same smoothing value that it's had before. Just like we're getting moving with our input get axis. Not sure how much of that's going to translate over there to Twitch, but it, at least here, no longer snaps, but actually moves softly as I move smoothly as I move my finger around. So, and if you want to change this, when you change this at home, you can change that smoothing value to more or less to give yourself some slightly different behavior. There is a problem with this. This is where we're talking about pointer IDs. I can describe this, but if I'm moving, and then I've got two thumbs now, I'm now moving the ship with a second touch by putting them both in that area. And we don't want that to happen. Not that you're really going to have two, I mean, the chances that you're going to have two thumbs in the same area is rare, because of the way that this is set up, but it's possible that you could get an accidental touch. And we don't want that to happen. So we need to look at and protect this whole touchpad area so that when we touch it for the first time, we don't allow any other touches. And also, we keep track of the touch ID, the ID, which finger this is. So if you were to touch it twice, not only do you not want to accept an input down, but you also don't want to have that other finger coming away. The biggest problem you have is a light touch. An accidental light touch will suddenly, it'll read the on pointer up, it'll zero out that location, and then won't give you a new origin until you touch down again. So that would be a problem. So let's go ahead and do this with a couple of private variables. So what we want to do is have a private bool, and that is touched. Have we touched this touch zone yet? And then we also want to keep track of, with a private int, a pointer ID. So we can keep track of which one this is. And then setting up our values here in awake, let's set up our touched to be equal to false. So when our pointer comes down, we first want to check, have we been touched? So if not touched, then we want to say touched is true. So just a little trap. So we've got a trap on our touched. And then we want to grab the pointer data. So if we want to set our pointer ID to be equal to the data dot pointer ID. And this is based on that touch ID. So when you look at the touches, this is being wrapped up for us inside the pointer event data that we're getting from the UI system. But ultimately, this comes down to the touches. It comes down to the touch ID, which finger is on the glass. So we grab that. So we've said we're touched. We make touch true. We grab the pointer ID, and then we set our origin. Now, in our on drag, we want to say if the data.pointer ID is the same as our pointer ID, then we can do all this work. But we don't want to do this work if the pointer ID is different. So if you end up with two touches, you can't set anything in pointer down because it's been touched. You can't set anything now in on drag because it'll have a different pointer ID. And then lastly, when the pointer comes up, that same thing, we want to say is if the data, oops, come back here, our data dot pointer ID is the same as our pointer ID. Then we set our direction to vector 3, 0, and our touched is equal to false. So we set that back down as well. Let's return that and that one. Thank you. So now we're protected. And we don't really need to set our pointer ID or our origin because they will simply be overridden the moment they're touched again. So I don't see any reason that we need to actually actively set those back to some default value. So again, back to Unity. All right. I mean, you're not going to be able to see very much, but essentially you're going to have to trust me that now when I do this and if I use 2 fingers on that spot, it's not going to break, especially when I deploy to mobile itself. The input modules are a little bit different when we're dealing even with remote in the editor, because technically we still are in the editor environment, so we're still on a mouse and keyboard device, though we're emulating that using the remote in my hand. But when I deployed earlier today, it worked a treat. So, fixing firing, and thank you for sticking through with me on this, but I do want to get this done in one long fell swoop, but I hate to say it, I did warn you. Fixing firing. Any touch right now causes the guns to fire. And now this could be acceptable behavior, but it certainly lowers the options that our players have. And I think that we should not make it possible for the player to fire while moving that way. They should, and that's partly why I reserved the other part of the scene, the other side of our movement zone. If we duplicate this, we can have our fire zone. And now I have an object. If you notice what I've just done, I've dragged the sprite but not the anchors. It's not really the best way to do that. We can come back up here and try to set the position there, with anchors in the corner, and then drag them back out again. They also, that works. The other thing that we could have done, because again, they have snapping, so this will be good. We could have simply changed these numbers by hand, move the rectangle of the image, and then change the anchors. Again, 0.5 is the middle on the X, but we want, instead of going to 0 and 0.5, we're going to 0.5 and 1, and we're still keeping it up there in that Y, about that bottom third. So now we've created a touch zone, and I'm going to remove that touchpad because we don't need it. We can then tap anywhere in that zone and it will fire the guns. I mean, I don't know if people have seen this with pinball games, where if you have a pinball game, you can tap the screen, and as long as you tap anywhere on the left-hand side, it does the left flippers, and anywhere on the right-hand side, it does the right flippers when you're doing pinball for mobile. So this is going to be very similar. There's no particular button per se, but clearly there's this zone that you can use to tap into to fire your weapons. So to fix firing, we need to make some changes to our player. We have that touch zone, and we need to change some things in the player controller, and then we're going to write a little quick script for that touch zone. The first thing we want to do, we want to get rid of this, essentially. The input get button is not what we want. We want to be able to, sort of a can fire Boolean. So we sort of need something that is a can fire Boolean that isn't going to be the button. The problem that we have with the UI tools at this point is that we don't have a button that will constantly continue to fire. So we need to be able to set a Boolean. So when the finger comes down on the button, say on pointer down, will turn the Boolean to true. And when the finger comes off, it does the on pointer up and it turns the Boolean off. So we have our fire zone that we've seen, which is what we want to touch. And we need to write a simple script for it. So let's go ahead and create another new simple script. And I'm being cheeky because I'm in a bad mood today. Let's call this something like, it's going to be very simple. Bad joke. Simple touch area button. Why? Because I couldn't think of anything better. And let's open that up in MonoDevelop. So let's go ahead and copy a good chunk, just because I want this to be quick. Let's copy a good chunk of this stuff out, and I'm going to edit it because we want all of the same kind of meat that we have for our touchpad, including the namespaces. And this will be a tiny bit quicker than me typing it in. So we've added our two namespaces, which is the UI and event systems. And then what we want to keep is that we want the up handler and the down handler, but we're not dealing with drag. So let's go ahead and I'll remove that in a second. So let's add those in. So we don't want the drag handler. So we want our I pointer down handler and our I pointer up handler. And then for values, we just want to keep our touched and our pointer ID, because we're going to need to do the same thing that we did with protecting the finger, so that we don't have, because if you're holding a finger down and then say you brush it with another finger, then it'll count the on pointer up and you'll stop firing even though your finger is held down on the fire button, which wouldn't be fun. And then lastly, we want a private, not a primitive type. We would like a private, please. No, it's because I've got stuff that's halfway through. It's not compiling. So private bool can fire. Let me just finish cleaning up this script because otherwise it's going to be nutty. And in awake, we'll leave our touch to false. Let's get rid of on drag completely. And that leaves us with our on pointer up. And what we're simply doing here, we're going to have the same trap. So if it's not been touched, then we want to set touch to true. And then we want to set our pointer ID, but we're not setting our origin today. We are setting can fire. So we have can fire equals true. So when the pointer comes down, we say we can fire. When the pointer goes up, again, we don't care about direction. We want to know our can fire is equal to false. And then we're going to do a very similar trick that we've done in the simple touchpad, where we can ask this script for the direction. We are going to simply have one down here, which is going to return a public bool, and it's going to be called can fire. And what that returns is simply, we're going to return our can fire value. Now we have our can fire. So if we come back to our player controller, our can fire Boolean is going to be simply can fire. So we need our area button. Remember our rather simple name that we created? Our public simple touch area button. I'm sad. Sad that I find that funny. And then let's call this our area button. And then what we can do down here is our can fire Boolean can simply be area button dot can fire. So if our area button.canFire is true and our time.time is greater than next fire, then we can fire our shot. Come back to Unity, and our player has a new reference we've got to drag. And so that reference is going to be our fire zone. Oh, because I haven't put it on yet. Duh. Full of face palming today. Touch area button goes onto our onto the unit, and then we can go ahead and grab that in our done player. And then our fire zone will be acceptable. Yes. Now again, into the giant mystery of the fact that you can't see a thing. Now I can maneuver. See, I'm maneuvering around. No weapons firing. I can reach over here. I can fire. So I now have move on the left, fire on the right, or both if I feel like it. So, there are some cleanup things that can be done to finish this conversion, which are optional. They pretty much include converting the text into new UI text and making a restart button instead of a restart on the keyboard. Right now, you cannot restart this on the mobile. Part of the nice thing about this is show you how quickly you can convert from our GUI text. So we've got our display text up here. Our display text is 3 GUI text items. What we can do is simply create a UI text item, and let's call this one our game over text. Let's change this to game over text, same as before, and then out of the way, let's make this white. And 24, I think it's about the same size. And we need to make it a little wider, so let's make this 200. And then we want it centered. Centered. And then we can also pop that up. 50. 75. Somewhere in there. 80. Overflow. Just overflow these anyway. So that's our new game over text instead of our old game over text. It's about the same spot. And then we want to duplicate that game over text. And then let's call this one score text. And score text, we're going to simply call this one score text as its text value. This is going to drop down to about 20. And then let's align that and move it into the upper corner. And then we want it aligned upper left as well. But we need to drop this down. I think it's going to be 10 and minus 10. Yeah. And so that's 10 and minus 10. So we can get rid of our score text. But we don't want restart text. We want a restart button. So we can remove that restart text. Now, let's make a quick button. So on our canvas, right-click to UI button, and we have our generic button. I've imported from standard assets a new slider button. So let's take a look at this slider button, and we want to bring this in as a sprite, and we also need to slice it. I don't want all that huge border. So let's make this a multiple sprite and apply that. And then let's do a slice automatic, should get it. Yeah, there's a bunch of JPEG-y garbage here. So also we need to change our compression. So we want to override for the iPhone and at least get it up to 16 bits, make it a little bit cleaner. So let's go ahead and slice that again. There we go, nice and tight. So that was just some sort of compression artifacting that was going around. And then with this particular slice, if you select that slice, we can come down and we can 9 slice it. How far is that? That's 5. Let's see what 5s all the way around do. That's looking good. So let's save that. And then on our button, this needs to be called restart button. Let's change out 2 things. The text should be just restart. And let's make it bigger. I think we're going to make that a little bit bigger, yeah. And then let's change out that artwork from the default sprite to our new slider button. UI sprite? Did I say that as a sprite? Multiple sprite? Apply. Did I not? Did I not apply? Oh, aye. That's, I must have forgotten to hit the apply button. So let's go ahead and slice that again. Slice. Select. 5s all the way around. And then apply. Yes, I guess when you swap off the sprite editor, if you haven't applied it, you have the chance of reverting those changes. So there we go. There's our sprite. And we want that. Turn it down. We want that slice. So come back to our restart button. And then, pow. There we go. Slider button. And then a color. White. Let's move this guy up into the corner. Again, using presets. There we go. Pow. And then -10 to bring it off the corner. And we have a restart button. I'm going to quickly just look at one more thing on that. Sprite editor. Bring it in a little bit. Because we want to get the full corner, because those corners are distorting. We might want 10. Get that full corner undistorted. And apply. Back to game. There we go. Better on the corners. Now let's hook these up. So we're going to need to open the game controller. Let's bring the game controller back online. And then let's go ahead and edit that game controller. And the first thing I want to do is we're going to need to use our using Unity engine. Oh, unsafe. Hey, let's do something that's totally unsafe. I love doing unsafe things, especially when I'm teaching. Unity engine. Okay, .ui. So we've got our UI namespace. And then we can come in here and simply get rid of the GUI and just call it text. Conveniently, that's about all we have to do. We don't care about our restart text. So let's get rid of that. Because if we look at score text and we look at where it's assigned, it now is assigning score text.text to score plus score, and game over text.text equals game over. And so all of the places that this is assigned, it's the same, because GUI text.text or text.text is the same syntax in the meat of the code, so we don't have to worry about that. The only place that we have to worry about here is we don't want to have our restart text be press R for restart. And we don't really care about update either, so we can turn that off because there is not going to be any update. We would want to keep that around for platform defines, but we're not going to do that right now. So we need one more thing. We need a public game object called lower R, please. Restart button. And then down where we turned off our restart text, we want to say our restart button set active to true. So we just turn on the button, and we also would like to make sure that this happens in start as well. So right now we don't need our restart text, but we do want to turn off that restart button. Oops, we need the E. So we've created our restart text and made those text that works just straight out of the box. We then create a game object called restart button. We set that game object to false when we start the game. And when the game is over, we set it back to true. We need to do one other thing, which is right now, it was if we held down the R key, we would set the application load level. We just reload this level. So we need to come up with a new function, a public void restart game. And when restart game is taken, we do our application load level. Oops. Let's get our brackets around it this time. We do our application load level. So now we are calling this because we have to call this as a function now from the button rather than enabling that, if restart and if input get key down R, then we application load level. We are going to simply call it from here. And it will be hidden because the button will be turned off. So we have our button, and we need to add a new row. And we want to... I thought we turned you on. So we add our game controller, and we look for the done game controller restart game. So the button will allow us to restart the game, but we will only see that button when we lose. The last thing we need to do is on our canvas, because we want to be resolution independent, we want to add a canvas scaler. Canvas scaler can be found just under add components, and I've already typed in CINV for canvas, and there's canvas scaler. And we want to scale with screen size. And we want to start with our reference resolution. We've been using 640 by 960, 640 by 960 as our reference resolution, and we're going to match height and width. I mean, in one sense, this game should always be portrait, so we could probably always get away with width. But let's save that. Game controller. We still have to hook them up just because we fixed them in the script. So we've got our game over text needs to be hooked up. Our score text needs to be hooked up. And our restart button as a game object needs to be hooked up. Because that was causing some reference problems. All right. Oh. Boom. And so now, just as it did before, we should clear the screen. We should get our restart button. I click the restart button. We're starting the game again. So complete functionality moved over to touch device. We have our game over. We have our score. And in the case of having a keyboard command, we now have a button that allows us to... All right, there you have it on mobiles. Now, deploying and building is going to be slightly different for each one. But build and run, it'll build. In my case, it's going to build a project and open it in Xcode. When I do this, I like to create a new folder called builds. And note that they're in my project, but at the root level. You do not want them in your assets, libraries, project, or temp folder. No, you only want them if you want to do this build folder inside your project. So it stays with your project. Make sure it's there alongside at the top level. And then I can save this as whatever, iOS build, or space shooter for iOS. And remember, this can be done for mobile. This can be done for not mobile. It can be done for Android. It can be done for Windows Phone. So this doesn't make a difference as to which mobile this is. It just happens to be that I have iOS devices here in my studio. Now, I'm presuming this is going to work. I haven't double checked all the settings. It's somewhat irrelevant what we're going to see, because you won't be able to see it deployed on the device. But this will open the Xcode project and deploy it onto my machine. It's opening Xcode in the other window. I'm not sure if there's something we really want to wait for while we're here. But a couple of questions if you want to. That's sort of it. Did you have anything? I don't really want to go off topic today because we've been here for so long. But if you have a question about today's episode, throw them in the chat channel. I'll go ahead and answer them. But I'm not. I don't think we really have time to answer questions that aren't related specifically to tonight's session. Oh, I've got the remote open. Sorry, it's not going to build. I don't know whether it's going to pick up or not, because I still had the Unity remote open. So it wasn't clean to do that. We will include the code. I'm reading the question. Soylent Pete. Not Soylent Pete. Someone else has asked that. You were answering it. But anyway, for this particular field... Oh, no, it's running. It's fine. Hey, high resolution and everything. I don't know if you can hear it, but that's it playing with sound and everything, except for the background music. It's playing on the device, so it looks good. But yes, we will include the code with it. Did I add 2? Oh, whoops! There should only be 1. Is that now automatic? Oh. That's just me out of habit adding a canvas scaler because I'm not used to having them there automatically. There shouldn't be 2. That's entirely my bad. But yes, it looks like they now come default with a scaler on them. See what changes sneak up on you? Yeah, it does. Oh, silly me. All right. Don't. Just set it. Yes, that is a change. But a very good question. The remote, what is the remote? The whole point to the remote is that if you are testing touch input, to save you from making changes and having to go through the deployment phase every single time, then you can attach the remote. You can use it for accelerometer input. You can use it for touch input. When looking at the remote itself, the graphics are incredibly low resolution because it's sending information back and forth across the USB cable. Terribly compressed. You're not supposed to be looking at the screen of the device for any fidelity. And some people freak out and go, oh no, I'm looking at the device and my game looks like a carp. And well, it's supposed to, because it's only for giving input. You really need to be watching the screen to see what the graphics are going to look like. I mean, sorry, watching the screen on the editor. You need to be watching the editor to see what the graphics are going to be looking like. Gold Data asks, can you use the touch control today to put the area on the bottom side of the game screen to create a drag-like effect on the game? I'm not quite sure I understand the question. I'm going to read this again. Can you use the touch control that we made, I'm assuming that we made today, to put an area on the bottom size of the screen to create a drag-like effect? Yes, you can put that area, an area anywhere with an image. You can put it over your entire screen. You can also poll the touches directly. You don't necessarily need, if you want to test the whole device, you can just ask for touches. The main advantage of using the image is that you don't have to define a rect. I mean, one of the ways that you can do it is you can also simply define a rectangle, and then look at the touches and say, hey, are the touches inside this rectangle? And if so, then I want to operate on them. However, what's convenient about the image is that you have a lot of this stuff built in. It's all in the same mindset. It's part of your canvas. The touches arguably are part of the user interface. And so to have a fire zone and a movement zone or a proper joystick all under the canvas as part of your UI, it starts to also make sense mentally when you're organizing your project. The question from Terpain was, what did you use Xcode for? The answer is I didn't really use Xcode. However, Unity sent our project to Xcode because you need Xcode to build this into an app and put it onto the phone or onto the iPad at this point. This is the environment, a little bit like Unity has the Unity editor, Apple has Xcode, to be able to do the build that takes the project that Unity spits out. Let me show you this. So we've got our project. Oops, wrong button. So here's our project with our assets. Oh, I must have missed. That's supposed to go into the build. Normally I drop that into builds. I must not, in my rush. And then, so inside, close. Xcode didn't like me moving it, which makes sense. So inside this particular project is an Xcode project, and all of the material that Xcode needs, all of the lists and libraries and things that if you were, say, building an app in Xcode for the Apple App Store, all of that has been created for us, and there's the build. All of that has been created for us by Unity in a nice little folder, and then Unity goes and kicks Xcode in the shins and says, load this project, I need you to do something for me. And then Xcode just builds the project as long as there are no overt problems. And that's similar to what happens with Windows and Android as well. If you notice inside the preferences, I think it's in external tools, you can set up where is your Android SDK root folder. Because on the Mac, Xcode is easier to find, we don't have to hook it up inside the external tools. The Android SDK needs to be hooked up here in preferences so that when you build to Android, it knows where it goes. I mean, as a matter of fact, you can try it and watch where it's going to error. Watch the errors. Android, switch platform. And I don't have the Android SDK because I don't have an Android device, sad to say. SDK is Software Development Kit. Sorry, Terpain asks, I'm new to Unity, so what is SDK? It's short for Software Development Kit or Software Development Kit. And you're given the development kit to be able to build software for that platform. Now, if we tried to do a build and run, it's going to tell me I don't know where Android is. It should. Somewhere in this process, it's going to tell me that it doesn't know where Android is. But I did want to show you that I simply changed from iOS to Android, and it's going to be my lack of the SDK that's going to stop me from building, not the code that we've written. Falcrons asks, I may be asking something simple. Is the effort level within the scope of this project to add support for VR, such as Gear VR for the Note? I mean, this particular project isn't set up for VR really, just because of the nature of the nature of this game. You probably would never want to use it for VR. But you can, I mean, I don't think there's anything that's preventing you from doing VR. I know that you need special shaders for doing Oculus VR because it's taking the camera and bending it onto a single screen for two lenses. And you need to run that through through an appropriate shader, I believe. So, Oculus Rift. But let's see if we can get some interesting images. Because you usually, if you do this, yes. You can see what it's doing is that one of these areas is the single screen. And then this warping and distortion goes onto the single screen that's inside the VR device. And then the two lenses undistort this and give you that sense of being surrounded by your environment. So nothing that we've done today will prevent you from doing VR, but this isn't a particular type of game you'd play with VR. And you'd also need some additional experience and resources, which should be provided by those people who are doing the VR, whoever is making the SDKs for the Samsung stuff. All right. Any last questions? And then I'm going to go ahead and wrap it up. Sorry, it was so rushy, but I really didn't want to split it into 2 sessions. And I did want to cover enough of the stuff around it, but I'm glad you were patient. All right. Well, I'm going to go off mic. Thanks for coming. Thanks for sticking through. Thanks for saving. Let me get my Twitter sphere and stuff back up here. So you can go ahead and follow us. You can follow us at Unity 3D. You can follow me at The Ant Ranch. You can follow Will at Will Goldstone. You can follow Matt at Matt Mirrorfish, and Mike, who was here earlier today, as at Mike Geig. You can also. So thanks for coming, and I will see you next week when we try to load scroll lists at runtime with buttons. I know it can be done, honest. Anyway, I'll talk to you guys later.